Now that we've looked at an example of a strong linear relationship and a line and equation that fit through them, let's talk about how we can use that equation. So a regression line has the equation y equals mx plus b, where x is the explanatory variable and y is the response variable. So we can predict y values or values of the response variable by plugging values of x into our equation. So we'll pick values of the explanatory variable, we'll plug them in, and they'll give us a prediction for the response variable. This is known as interpolation, and that's because you want to pick values of x that lie amongst the points you already have. So they're in between all the points that are already there, which is giving us interpolation. All right, so let's go back to our example with the ice cream sales and the temperature. Remember, they recorded the temperature at noon and then also plotted the day's sales for ice cream to see if there was a relationship. There was a nice, strong linear relationship. They gave us the equation y equals 33x minus 216. So one way we could use this is suppose we wanted to make a prediction for what our ice cream sales will be based on the temperature being 21 degrees. So let's start by guesstimating this from our graph. So I want to go along the x-axis where my explanatory variable is until I find 21 degrees. And then I'll go straight up until I reach the regression line. And then to get my prediction, I'm going to head back over to the y-axis where my response variable is. So it looks like it's just short of $500, maybe about $475 or so. To get the exact value of the prediction, we're going to plug that 21 in for x. So that'll look like y is equal to 33 times 21 minus 216. And that gives us a total of $480. So if I was going to interpret this prediction in context, it would sound something like when the temperature is 21 degrees, the predicted ice cream sales are about $480. And picture-wise, that point for the prediction is this point right here where the $480 and the 21 degrees line up. And all of your predictions are always going to sit right on the line. That's how that's going to work. Right, now that we've taken a look at how to make predictions and interpret them, what I'd like for you to do is to go ahead and practice that skill. So on the notes, you'll see you have two examples. The first one is about the number of hours of video games played and the number of push-ups someone could do. And then the other one is about distance traveled and the airfare cost. Both problems ask you to start by identifying the explanatory and the response variable and then to do some predictions. So go ahead and pause the video and give that a try. All right, so hopefully you gave that a try. Let's look at this first one. It says the relationship between hours of video games played per day and the number of push-ups a person can do is given by the following model where X is the hours of video games played. So our explanatory variable is going to be the hours of video games played per day, and our response variable is going to be the number of push-ups. So we're supposed to predict the number of push-ups a person who plays 6 hours of games per day can do. So I'm going to put 6 in for X, and that gives me a total of about 30.6. So that interpretation is a person who plays 6 hours of video games per day can do approximately 30 to 31 push-ups. And then the second problem, so our explanatory variable is going to be the distance in miles, and our response variable is the airfare. Measured in dollars. So we were asked to make two predictions on this one and then plot them on the graph. So the first one asked us to make a prediction if you're flying 370 miles. So I'll plug 370 in for X, and that gives me about $126.56, which is where this red star is right here. And then they asked us for a longer trip. So that prediction was 1,502 miles. And so that gives me $259. You notice that that actually is right out on the edge of the line. And what we're going to talk about in the next video is what happens if we go out past where our points are hanging out at, and is that a good idea or not? So I'll see you back in the next video where we talk about extrapolation.